Let's start with the scale of what we're dealing with. I want you to think about this carefully because most people don't really appreciate how enormous the numbers are. Our sun is a pretty ordinary star, right? Nothing special about it. In our galaxy, just one galaxy, there are at least 100 billion stars. Some estimates say 200 billion. Now, for each of those stars, we've discovered that having planets around them is completely normal. It's not rare at all. In fact, most stars have planets orbiting them, and I mean most. We found over 6,000 confirmed exoplanets so far, and that number keeps growing every month. But here's what really blows the mind. Astronomers estimate, based on the data we have, that there might be somewhere around 1 trillion planets in our galaxy alone. 1 trillion. And each one of those is a world. Each one has a surface, a potential for chemistry, for processes we might not even have thought of. Now you might be asking, okay, Feynman, so what? A lot of planets exist. What does that have to do with aliens? Well, we're not looking for planets that have alien life on them. We're looking specifically for habitable planets, places where, at least by our understanding, life could exist. Scientists have this concept they call the habitable zone. And I love this term because it's honest about what we're doing. We're making assumptions. We're saying if a planet is at just the right distance from its star, not too hot and not too cold, then liquid water could exist on its surface. Now, on Earth, as far as we know, everywhere we found liquid water, we found life. So we're basically betting that liquid water is a pretty good sign. It's called the Goldilocks zone, which I think is one of the worst names in science because it's way too cute for something this important, but okay. Here's what they've calculated. Based on data from missions like Kepler, astronomers have estimated that there could be somewhere between 40 and 180 billion planets in our galaxy that sit in the habitable zone of their stars. Let me say that again. At minimum, 40 billion. That's not a typo. That's 40 billion worlds where, by our understanding, life could potentially exist. So this is where the logic seems airtight, right? Trillions of planets, tens of billions of them in habitable zones. The universe is 13.8 billion years old. Life emerged on Earth almost as soon as it could have. The math says life should be everywhere. And yet, and this is the crucial part, we have found absolutely nothing. No signals, no visits, no confirmed microbial fossils in meteorites, nothing. This problem is so famous among scientists that they've even given it a name. It's called the Fermi Paradox, named after the physicist Enrico Fermi, who supposedly asked at lunch one day, "Where is everybody?" And that's the puzzle. That's the real puzzle. Not whether aliens exist. Statistically, they probably do. The puzzle is why we don't see them. Why can't we find them? Where are they? This is what I mean by aliens are already here, but we can't see them. They're hidden by the sheer distance of space and the limitations of how we search. Let me talk about what we actually know about the search so far. People get excited sometimes when they think we found evidence of alien life. And I want to be honest with you about what counts as evidence and what doesn't. The problem is, we don't even have a good definition of what life is. I know that sounds strange, but it's true. On Earth, we say life is something that can replicate itself, something that undergoes evolution, something that maintains itself and uses energy. But there are hundreds of definitions, and every single one of them is based on the only life we know, us. Carbon-based, DNA-using, cellular life. But what if life somewhere else doesn't use any of those things? What if it's based on silicon? What if it uses some kind of chemistry we've never imagined? Then all our definitions fall apart. So when astronomers look for what they call biosignatures, chemical signatures that suggest life, they're really making educated guesses. They're saying, on Earth, this molecule is only made by living things, so if we find it somewhere else, maybe it's a sign of life. But here's the problem. Just because something is only made by life on Earth doesn't mean it can only be made by life everywhere. Recently, there was a lot of excitement about a planet called K2-18b. It's about 124 light years away in the habitable zone of its star. In 2023, using the James Webb Space Telescope, researchers detected a chemical called dimethyl sulfide. On Earth, this molecule is produced only by living things, mostly tiny organisms in the ocean called phytoplankton. So the headline said, "We found signs of alien life," and people got very excited. But, and I want you to listen carefully, other scientists immediately said, "Hold on, because we've made this mistake before." In 1976, we sent Viking landers to Mars. The Viking missions had experiments designed to detect microbes in the Martian soil, and the results looked promising. One experiment seemed to show signs of living organisms in the soil. Scientists were excited. But then other experiments on the same samples found no organic compounds, no signs of complex molecules that you'd expect from life. And later, scientists found that a mineral on Mars called perchlorate could create the exact same chemical reaction that made people think there was life. So it was probably just chemistry, not biology. This has happened before, and it happens again. We see what we hope to see. K218b is a good example. The signal for dimethyl sulfide was very faint. There's disagreement about whether it's really there. And even if it is, it might have been created by chemical processes we don't understand yet. The concentration they found would be extremely high if it came from life, which is interesting, but interesting isn't the same as confirmed. Here's what I think is important to understand. Finding life is hard. Actually, let me say that differently. Confirming that something is actually life and not just chemistry is genuinely difficult. We need multiple lines of evidence. We need independent confirmation. We can't just find one thing and say, that's it, we found aliens. We need to look again. Think about alternative explanations. Check our assumptions. So where could life actually exist? We don't know, but let's think about the possibilities. In our own solar system, there are a few interesting places. Mars, for instance. We know now that Mars had liquid water on its surface billions of years ago. There might still be water underground. If life ever got started there, it might have retreated underground to stay liquid. We've sent rovers to Mars looking for signs of ancient life, and the possibility is tantalizing. But again, we have found nothing. Jupiter's moon Europa is interesting. Under a thick layer of ice, there might be a liquid ocean. That ocean could be warmed by tidal heating, the moon getting squeezed as it orbits Jupiter. Some of the most extreme environments on Earth, places we thought were impossible for life, turned out to be teeming with organisms. Scientists call these organisms extremophils. They live in boiling hot springs in the deep ocean near volcanic vents, in rocks miles underground with no sunlight and no connection to the surface world. These organisms don't need sunlight. They don't need organic material from the surface. They just need liquid water and some kind of chemical energy source. This changed everything about how we think about where life could exist. If life can survive under miles of ice in the dark with weird chemistry, well, then maybe Europa's ocean isn't so impossible after all. But here's the thing that gets me. Even if we found microbial life in Europa's ocean or in the rocks under Mars, that would only give us two examples of life in the universe, both in our own solar system, both near Earth. That's still not very many, and the universe is incomprehensibly large. The distances involved in space are so enormous that even the word enormous doesn't really capture it. Let me try to give you some perspective. Light from the nearest star to us, other than the sun, takes 4.2 years to reach us. That's how long light travels at the fastest possible speed. K218b is 124 light years away. That means the light we're seeing from that planet left 124 years ago. When we point a telescope at it, we're not seeing the present, we're looking at the past. And we're getting just a tiny amount of light reflected from the planet's atmosphere. The James Webb Space Telescope, which is our most sophisticated instrument for looking at distant planets, had to spend hundreds of hours, that's actual observation time, on one of the most expensive instruments we've built, just to get a hint of a chemical signature from one planet. And even then, scientists disagree about whether the signal is real. Now think about what this means for the possibility of visiting or being visited. The nearest star is 4.2 light years away. With our current technology, a spacecraft would take tens of thousands of years to get there, even if aliens existed, even if they were advanced and smart and had better technology than us. The distances are so vast that casual interstellar visiting doesn't seem feasible. You'd need generation ships. You'd need a reason important enough to spend centuries traveling through empty space. And even more than that, if an alien civilization did exist and did have technology to travel between stars, they still face the problem of time. Civilizations rise and fall, planets change, technology breaks down. Any civilization visiting Earth would have to do it in a pretty narrow window where they have the technology and we haven't destroyed ourselves yet or radically changed. It's not impossible, but it's not as simple as a lot of people imagine it to be. So this brings me back to the original question, where are they? And I think there are a few possible answers, and I want to talk about what each one means. One possibility, and this is actually what a lot of scientists think might be true, is what they call the Great Filter. The idea is this: there's some incredibly difficult step in the chain from non-life to advanced civilization. It's so difficult that it almost never happens. Maybe it's getting from chemistry to the first living cell. Life did emerge on Earth, but maybe that was incredibly lucky. Maybe it happens only once in trillions of planets, or maybe the filter is later. Maybe life emerges pretty commonly, but getting from simple microbes to intelligent beings is nearly impossible. Or maybe it's the fact that intelligent civilizations keep destroying themselves. Another possibility is what they call the zoo hypothesis. This one's kind of fun to think about. The idea is that alien civilizations do exist, but they're deliberately not contacting us. Maybe they're like we're in a nature preserve. They observe us but don't interfere because they want to see how we develop naturally. Or maybe they've agreed to stay hidden from younger civilizations. It's a bit science fiction-y, but it's not logically impossible. Or there's another possibility I find interesting. Maybe intelligent life exists, but we're just looking in the wrong way. We've been listening for radio signals. We've been looking for visible light. But what if aliens communicate using something we haven't even thought about? Or what if their technology is so advanced that what they use looks like natural phenomena to us? But here's what I think is the most honest answer. We don't know. We simply don't know. And that's okay. That's actually where the best science starts. When you don't know something, that's where the mystery is. That's where the interesting questions are. What we do know is that the sheer scale of the universe strongly suggests life should exist elsewhere. The chemistry that gives rise to life, carbon, water, the basic building blocks, that's everywhere. We found organic molecules in meteorites. We found them in the clouds of gas between stars. We found amino acids on asteroids. The chemistry of life seems to be written into the universe itself. But we also know that finding life, confirming it beyond doubt, is a lot harder than people realize. And we have to be careful not to see what we want to see. We have to design our experiments carefully. We have to get independent confirmation. We have to think about what else could produce the same signal. Here's what I think is happening. I think the universe is probably alive with simple microbes. I think life probably emerges on a decent fraction of habitable planets. But I think intelligent technological civilizations are probably rare. I think the great filter might be real, and maybe we've already passed it by luck, or maybe we're about to hit it. I think the distances in space are so huge that even if intelligence is common, actually meeting would be extraordinarily difficult. And then there's another possibility I haven't mentioned. Maybe aliens are here, but not in the way people usually imagine, not visiting in spaceships, but maybe as microbial life that arrived on meteorites, maybe as biochemical processes we don't recognize as life, maybe as something we just haven't thought of yet. But I think the most important thing is this. The fact that we haven't found alien life yet is not evidence that it doesn't exist. It's just evidence that either it doesn't exist or finding it is much harder than we thought, or both. We need to keep looking. We need to send more rovers to Mars. We need to look at Europa. We need to build better telescopes. We need to think more carefully about what we're looking for and how to recognize it. And meanwhile, this puzzle, this beautiful, frustrating Fermi Paradox, it keeps us thinking. It keeps us curious. It reminds us how much we don't know. And I like that. I like mysteries. Mysteries are what science is for. So are aliens already here? Well, not in spaceships sitting in secret government warehouses. I think that's probably not true. But if we're honest about the scale of the universe, they probably exist somewhere. We just can't see them yet. And maybe that's the most interesting answer of all. Because it means we get to be the searchers. We get to look out at the universe and try to figure it out. We get to ask, where is everybody? And we don't have a good answer yet. And I think that's wonderful.